Hello, my name is Brian Walchek, and I'm doing the video for the Orange Team for Cycle 3. Now, the theme for Cycle 3 is safety and reliability. So, as part of the Orange Team, our subtopic was increasing the reliance on embedded systems with a focus on safety, redundancy, and software failures. So, to start, small-scale computer systems have rapidly become part of our lives. Everything that we use nowadays um, has some sort of computer in it, or a chip, or a sensor that makes it easier and more convenient for us to use. So, to start off, definition of an embedded system is exactly what it says. It's a computer system with a dedicated function within a larger mechanical or electrical system. So an example of this could be, um, a car, or something like this heat gun. Um, this has a purpose of, um, heating up material to either adhere it to something, or um, just use it as a, I don't know, but honestly, I use this to fix iPads. So, um, but just by, I guarantee, if I open this, there's chips and things inside that say, you know, restrict the heat gun to this temperature, or, um, you know, keep the fan at this speed. So, something as small as this heat gun, or something as big as a train or an airplane, but they all have embedded systems in them. So, to start off talking about safety, um, there's definitely safety concerns with this technology because it's become ever so popular in our society. And, you know, since its increase in size, it's definitely been more concerning to developers, just because their main focus is to make the code that they use as safe as possible. But, sometimes they're not able to do that just because of the amount of people that are relying on their systems to function in their everyday lives. Um, just as another example here, um, I have an iPhone that has all these different chips inside it, and location devices, and pretty much everything you need. We rely on these cell phones every day, and there's no knowing if one of the systems within it could go bad. But for something as small as this, people aren't going to make a big deal about it. But um, just recently in the news, there was the recall for, I think it was over 14.5 million vehicles, I believe it was, for the, maybe it was 4.5 million vehicles for the Takeda airbag recall. And that's one of the biggest recalls in U.S. history. So the safety concern with that is, how do we prevent these people from not getting injured, because it's going to take us 7 years to um, produce all of these airbags again. So, who could have pictured that 7 years down the road, the death toll from this, or injury rate, could be 20% higher. So, um, the systems within the airbag um, are being revamped basically by the company. Um, but a traditional application for the high standard of safety for these systems is in the use of military and aerospace vehicles. Um, for one, the military has a lot of money to spend to make sure everyone that's fighting and everyone that's around them is safe, which I don't blame them. But when it comes to consumer electronics, like I said before, we're basically out of luck. We're given a warranty, and if something happens after that warranty, it's basically out of luck. And um, companies will use like a new generation of an electronic device to cover up what may have been flawed on the old ones. Um, but just a quote here from one of my sources was, um, considering the analog braking system and traction control on today's automobiles, the safety systems are each managed by software running on a networked set of processors, and the failure of any of these systems sparks major safety concerns that could lead to recalls and lawsuits. So, I know a couple years back in 2008, I believe it was, there was a huge Toyota recall about an accelerator getting stuck, and people just losing control and not being able to stop their vehicle, which resulted in um, a death toll that was way too high for any automotive mistake. And the standards for these manufacturers have been increasing over even that 7-year span since that last Toyota recall. But um, back then they didn't have the same code. They used different variations, and constantly came up with a new system that may or may not be better. But that leads me to my next topic, which is redundancy. Um, you know, the modern networked embedded systems that are found in automobiles or spacecraft or self-orbiting satellites consist of hundreds of computational units. And a unit may be made up of one chip, but it may have 1,000 chips inside it. So, um, for example, our computers aren't just one piece that makes it work. There's thousands of components that go into making a computer. Um, and let's see here. The functions of this redundancy is basically they find code that works and that's safe, and this existing data redundancy is used to create the reliability and increase it within the system. I mean, just because a system may not function properly one year, um, there's software engineers right behind them saying, what went wrong here? How can we fix it? And if they have consistent success, they're not going to fix it just because it's so, if it's perfect, why change it? Um, if there's no failures or software failures, um, they're going to keep using the same code. So that leads me to failure. And, what failure is um, basically when there's a bug in the software, or um, someone reports or a problem with their vehicle, or even an electronic. Like I've seen at Walmart, for example, on the recall wall, there's toys that may still contain lead, which that's their call on whatever they're doing. So um, yeah, so for example, with failure, space systems, every component is potential point of failure, because um, it's not just an embedded system for a spacecraft. It's composed of um, software applications as well, and um, you know researchers have made attempts to make the systems within a spacecraft more secure, but both of them, they fail after a while because the security breaches are so high with people just trying to hack in. I'm currently interning at Orbital ATK, and I get an email probably once a week saying that um, someone tried to hack our network, and that's why they say don't keep personal documents or your work information, social security numbers on the computers just because they are attempted to be hacked so frequently. Um, and another reason why the software fails is just the complexity, and the information systems nowadays just overwhelm the engineers that are trying to keep people that may be up to no good out of their business. So it's not that they're lazy, it's just that um, the technology keeps increasing, and there's could be someone that's one step ahead of them. Um, so that really sums it up. With safety, the safety concerns among automobile drivers are obviously more prevalent than someone who's going out to buy an iPhone, because if your brakes fail, it'll kill you. But if your iPhone drops a call, it's not the end of the world. So I think that until embedded systems become more efficient, that's when they will um, implement that technology into our handheld devices. And the redundancy is as simple as they have an efficient code and an efficient method, so they're going to continue to use that until either someone figures out how to mess with it or until it's outdated. But um, and it all sort of bases on each other. And with software failures, that's just part of bases off of redundancy, where um, if you don't use the same code, if you try something new, and you know, if you're buying a first generation of a new model of a car, um, reviewers always tell you never to buy the first year, because that's when they have all the kinks and all the problems, and you know, they fix those by the second or third year, so you could feel more confident in buying something later than earlier. So, um, yeah, so these are just the safety issues and concerns among consumers and even developers with the reliance on embedded systems. So, um, that concludes this video. Thanks for watching.